When the James Webb Space Telescope turned its finely tuned instruments toward Pluto, the results surpassed all previous expectations. The imagery it delivered wasn't just clearer than before. It fundamentally changed our understanding of the dwarf planet. Pluto, long shrouded in icy darkness and mystery, remained enigmatic even after NASA's New Horizons conducted a groundbreaking flyby in 2015. Although that mission provided key insights, numerous questions about the distant world remained unresolved. Now, with Webb's exceptional infrared sensitivity and unprecedented resolution, Pluto is being viewed with clarity once deemed impossible. These observations carry significant scientific weight. Once classified as the 9th planet in our solar system, Pluto continues to captivate researchers and sky watchers alike. Located in the Kuiper Belt, more than 3.6 billion miles from Earth, Pluto has always posed a challenge to study in detail. Earlier telescopes, including the well-known Hubble, only managed to produce blurred visuals of its surface. However, Webb, positioned beyond Earth's atmosphere and equipped with a 6.5-meter mirror, has transformed how we observe such remote celestial objects. Its ability to collect light from extremely distant regions has made it possible to discern surface details, atmospheric structures, and geological activity never seen before on Pluto. What makes Webb's contribution especially notable is the way it observes the cosmos. Instead of relying on visible light, it primarily detects infrared wavelengths. This means it can sense heat and subtle temperature differences that visible light telescopes simply can't capture. When used to study Pluto, this ability allows scientists to peer through its thin atmosphere and notice shifts in surface ice and evidence of possible internal activity. A recent image jointly released by NASA and the European Space Agency shows Pluto's surface in a level of detail never previously attained. The data includes visuals of plains made of nitrogen ice, mountainous terrain, and hints at possible seasonal variations in Pluto's sparse atmosphere. One of the most notable revelations is the enhanced imagery of Sputnik Planitia, the iconic heart-shaped region first seen by New Horizons, previously known to consist mostly of nitrogen ice. Webb's infrared view revealed deeper textural patterns and brightness differences, which point to active processes, perhaps sublimation or ice accumulation occurring on the surface. This suggests that Pluto, despite its distance and freezing temperatures, might still be geologically alive. The telescope's observations have also unveiled new information about Pluto's atmosphere, a thin envelope composed mainly of nitrogen with traces of methane and carbon monoxide. Although the atmosphere is faint and extremely cold, the infrared sensors enable scientists to detect temperature gradients and shifts in chemical composition. These findings help track changes in atmospheric pressure and temperature over time, offering clues about Pluto's extensive seasons, which span its 248-year orbit around the Sun. In addition to Pluto, Webb has offered improved views of its 5 known moons. Among them, Charon, Pluto's largest and closest companion, stands out. Roughly half Pluto's size and locked in a synchronous orbit, Charon has intrigued scientists for decades. Webb's observations reveal new surface details, including signs of frozen ammonia and complex hydrocarbons. These findings suggest that Charon may have experienced a more geologically active past than previously believed. Webb has also imaged the smaller satellites Styx, Nix, Kerberos, and Hydra. These moons, typically hard to study due to their diminutive size and remote location, can now be analyzed with greater precision. Researchers are gaining better insight into their paths, surface compositions, and possible formation histories. These discoveries are gradually building a more comprehensive picture of the Pluto system and shedding light on the dynamic nature of the outer solar system. Perhaps even more intriguing is the renewed relevance of the debate surrounding Pluto's Classification. Although the International Astronomical Union designated Pluto a dwarf planet in 2006, Webb's data indicates a level of complexity from geological layering to an active atmosphere and the possibility of subterranean oceans that rivals characteristics seen on planets. This challenges conventional criteria for what defines a planet and reignites the discussion about Pluto's status. The telescope's high-resolution images also highlight the scientific potential of further exploring the Kuiper Belt, a vast region beyond Neptune filled with icy bodies. With Webb's precision, astronomers can now focus on other targets in this region, such as Eris, Makemake, and Haumea. Each of these icy worlds holds clues about the formation and evolution of the solar system, unlike Hubble, which primarily captures visible and ultraviolet light. Webb's strength lies in its infrared capabilities. This allows it to see through cosmic dust, detect faint sources of heat, and identify objects too cold or distant for previous instruments. This capacity is especially valuable when observing frozen celestial bodies like Pluto, which emit little visible light but glow in the infrared spectrum. Webb's success in capturing detailed imagery of Pluto is a powerful demonstration of the telescope's advanced design and capabilities. To achieve this level of detail, Webb's guidance systems had to flawlessly track a small, fast-moving target while accounting for its own movement and Pluto's slow drift through space. This level of precision highlights the telescope's flexibility in studying both ancient galaxies and nearby dynamic systems, including those within our own solar neighborhood. Its adaptability paves the way for future studies of other intriguing objects, such as Neptune's moon Triton or additional large Kuiper Belt bodies. With each new observation, our understanding of the solar system's outermost frontier grows. As researchers continue to examine Webb's data on Pluto, new questions emerge. Could a hidden ocean lie beneath Pluto's icy crust, similar to those suspected on moons like Europa and Enceladus? What drives the evident geological processes in such an extremely cold and distant environment? Is it possible that cryovolcanoes are reshaping the surface, releasing volatile materials from beneath? Though Webb alone may not have all the answers, it offers essential clues to guide future exploration and scientific inquiry. Another major advancement enabled by these observations is the potential for comparative planetology studying Pluto. In the context of other icy worlds, scientists can now examine how Pluto's nitrogen cycle compares with that of Triton, whether it contains organic compounds akin to those found on Titan, or if its crust bears signs of ancient impacts or chaotic formation. These kinds of cross-planet comparisons deepen our understanding of planetary evolution, not just within our solar system, but in exoplanetary systems as well. Arguably, the most profound impact of Webb's observation of Pluto lies in its symbolic significance. Not long ago, Pluto was merely a blurry speck in even the most powerful telescopes. It seemed unreachable and unknowable. Today, we can examine its jagged mountains, frozen plains, and delicate atmosphere with astonishing sharpness. We can follow the contours of its heart-shaped region and watch its moon circle slowly through space. This represents more than a leap in planetary science. It stands as a tribute to human curiosity and determination. Every piece of data and every image results from the tireless efforts of scientists, engineers, and dreamers who push the boundaries of what's possible. The clear view of Pluto is a reminder that the cosmos still holds countless secrets waiting to be uncovered. From Pluto's initial discovery in 1930 to the New Horizons flyby in 2015 and now to Webb's game-changing observations, this journey has been one of constant innovation. The new insights not only deepen our appreciation of Pluto, but also usher in a new phase in the exploration of the solar system's outer edges. What we see now isn't just an image, it's a milestone, showing us that even the most distant worlds can be brought into focus, provided we have the drive and the tools to explore.